London's water demand is increasing. In East London, the largest water treatment plant is Coppermills, producing on average 500 million litres of water per day to approximately 4 million people. Coppermills Water Treatment Works is 45 years old, and we need to keep investing in our assets to ensure we can meet with growing demand. During certain times of the year, our output is reduced due to a big problem.
The problem with the RGFs is caused by what are called filter clogging algae. One of the types of algae that's in the water tends to block the first stage of treatment. This algae has cells that tend to join together in long chains, and these chains just won't go through the filter, but they form mats on top of the filter. There's a second type of algae that's made up of very small cells, and these get through the first stage of filtration, and these get held back by the second stage. A key to the success of this project was being able to understand the data that was available, and the way that we were able to format that data and look at the data enabled us to be able to demonstrate that the solution that's proposed provides the best value for money in delivering water for the people of London.
The RGF, or rapid gravity filter, has been the traditional solution to this problem for many years. Algae and other solids are removed from the water as it passes through the RGF media. As the algae and solids accumulate, the RGF is backwashed to maintain efficient water filtration. The challenge at Coppermills is to increase capacity by commissioning new RGFs in the remaining available area of land. The localised data analysis carried out by the team meant the RGFs could be designed to an optimal size, allowing the team to then focus on designing delivery innovations.
I was brought in April 2015 to look at the Coppermills project. We had a lot of work to do, building in innovation and saving time and money. In particular, there was a lot of scope for innovation in the RGF, and that's where Paul came in.
The RGF is a traditional filter, downward flow, going through a sand and anthracite media. The arrangement we've come to at Coppermills is 2 banks of 6 filters, and the difference between this filter is that we've brought the pipe galleries to the outside of the structure. What that's done is it's meant that the heavy items that normally go in last can be added to the sides, and therefore the lifting is easier and we can make them in the factory. So the intention there is to reduce site construction time.
We aim to reduce site presence by about 20 weeks. I took the approach of ensuring that the engineering was completed before we made the move to go to site. The big challenge to us was to move construction off-site and build it in the factory.
Coppermills is a great example of how collaboration and innovation can be combined in project delivery. Across the project, many left-shift initiatives are being deployed, which are delivering more efficiencies, better value and less time on site. Key to this was an integrated digital model. The model enabled all members of the project team, including the supply chain and Thames Water stakeholders, to visualise the new asset in the context of the Coppermills site and work together to solve the challenges posed by this complex project.
The deepest structure on the site is the low-lift pumping station, so we had to find an alternative way of dealing with that. We elected to use canister pumps grafted onto the existing 84-inch raw water mains, and instead of running 1600 diameter pipes across the site, we're now running 800 diameter pipes.
So here we have 2 canister pumps, with the pumps being located within the canisters. This is the existing 84-inch pipe, so rather than build a large wet well, we've got 3 locations with 2 pumps each.
At the very beginning of the project, we held a workshop to gather innovation ideas from all the members of the project team. We had some great ideas from everywhere, and that gave us a really good springboard to go in and decide what innovations we were going to do, decide how we were going to build this project, and then design it to those ideas. It's very important to know when to stop value engineering. The absolute key to this is doing it only once. Doing the design only once enables us to only construct it once, which enables us to commission it and get it taken over at the first pass. Coppermills is a great example of this and sets a template for all projects, no matter how big or small they are.
With all the innovation we're doing at this important site, we're ensuring the resilience of water supply to London for the future.